Hi, I'm Ben Zwickle, and welcome to this screencast on using Mathematica effectively in the lab. What I have here is an example of the most basic way to use Mathematica productively in the lab. This Mathematica notebook is an example of a way to combine data, plots, analysis like least squares fitting, and results all in one place. So here's the different sections. So here we have the data entered in as a table, execute by Shift-Enter. Here's a list plot of all the data. The next part is a nonlinear least squares fit. And then I'd like to view the best fit parameters and their standard errors. And lastly, here's the fit and the data shown together. So what we like to do is to turn this into a more reader-friendly document. We can do that by going to the Classroom Assistant palette, which gives us a lot of formatting options for our Mathematica notebook. Okay, so that appeared off screen. Let me make a little bit of room for it so I can show you the palette and the notebook at the same time. Okay, so here the two are together. And the first thing I'd like to do is to add a title to this document. So I can go to Title Cell, and I'll call this Using Mathematica Effectively in the Lab. And I'd like to add a subtitle for my name, so I can go to the Writing and Formatting sub-palette. And notice it also says Alt-2 does the same thing. And then we can divide this up into sections. So I'd like to add a section cell, which is Alt-4. This is the data entry. I'd like to add a section for the plot, Alt-4. I'd like to add a section for the nonlinear least squares fit. And a section for the results. So one of the advantages of dividing your document up into sections is by double-clicking on the bracket that encompasses the whole section, which is the one my arrow is pointing to right here. I can collapse or expand that entire thing. So that's helpful to make your document more readable when it gets really long. What I'd like to do here is add a little bit of text. So I'd like to add a text cell, Alt-7, and note that this was Beam profile data from September 28th, 2011. Alright, and I would also like to add a math cell. So in this case, a centered math cell, which is like a nice looking equation, which shows the fit function, which in this case was f of x equals a constant c times the error function, and inside the error function is a times x minus b plus overall offset. Another thing I'd like to show you is that we can do editing of graphics. So we can go to the Graphics Drawing Tools menu, and let me bring that on screen also. Here we can double click on the graphic to select it, and if I'd like to add an equation to it, I can click on this mathematical text and just click right here. And perhaps I'd like to put the fit function in here and then list the fit parameters. So f of x equals c times the error function times a x minus b plus d. And in this case, the fit parameter for just one of them was 155. So that's another powerful way to annotate your graphics. You can do that for any graphics, not just plot. And you can also do things like add arrows or draw shapes or add text rather than equations. And you can even change colors of different features of the graphics as well. The last thing I'd like to show you how to do is to copy in a graphic from another program. So copying images into Mathematica. So anytime you'd like to copy an image into Mathematica, it's as simple as treating it like a word processor. You can just select the image. In this case, it's in Microsoft Word, Control-C or Command-C to copy it, Control-V or Command-V to paste it, and there it is, right there in your Mathematica document. You can resize it. So I hope what this has given you is a sense of many of the different options Mathematica has for not just inputting your data, plotting it, and analyzing it, but also adding annotations and explanations that make your lab experience easier to understand and communicate to other people. So thank you for watching, and have fun.